Hello students, let us continue the session on playing with numbers. We had discussed exercise 3.2. Last question was question number 1. In this session, we shall continue with question number 2 onwards. The question 2 is to state whether the following statements are true or false. Look at the first one. The sum of 3 odd numbers is even. For that, I'll take some example. I'll take example of 1, 3 and 5. The sum of 3 odd numbers, the result is odd. So this statement is a false statement. I'll represent false statement with the letter F and the true statements with the letter T. Second one, the sum of 2 odd numbers and 1 even number is even. Let me consider some 2 odd numbers, say 5 plus 7. These are 2 odd numbers. This is added to another even number, say 4. The result is 16. It is an even number. So the statement is a true statement. Let's see the third one. See, the product of 3 odd numbers is odd. Suppose if I consider 1, 3 and 5, the product is 15. Let me consider in random some other 3 odd numbers, 3, 5 and 7. 35 multiplied to 3 is 105. It is also odd. So this statement is a true statement. Next statement, D. If an even number is divided by 2, the quotient is always odd. This is a false statement. The reason is, suppose if I consider one of the even numbers at 20, and if I divide by 2, the result is 10, and this 10 is not an odd number, it is an even number. Say if I consider 16 divided by 2, I get 8. These are even. So this statement is a false statement. Fifth statement, all prime numbers are odd. It's a false statement. The reason is, the first prime number 2 is even. It is the smallest prime and also the only one even prime. So this statement is a false statement. Statement F. The prime numbers do not have any factor. This statement is also a false statement because we define prime numbers as the numbers having exactly 2 factors. Suppose if I consider 13, 13 is a prime, it is divisible by 1 and 13. So there are 2 factors. So any prime number will be having exactly 2 factors. So this statement is a false statement. Sum of 2 prime numbers is always even. This statement is also a false statement. The reason is, if I consider 2 prime numbers, say 2 and 3, I get the sum as 5, which is an odd number. Next statement, 2 is the only even prime number. This statement is a true statement. All even numbers are composite numbers. It is a false statement because 2 is an even number and it is not a composite number. The product of two even numbers is always even. This statement is a true statement. Say for example, if I consider say 4 an even number multiplied to another even number, say 6, the product is 24. We shall see question number 3. For third question, we have to have combination of the numbers between 1 to 100 such that the pairs are like 13 and 31, that's the digits are interchanged. So we have 13 and 31, likewise 17 and 71, 37 and 73, 79 and 97. Here the digits are the same numbers but places are interchanged. Let us look at the next question, question number 4. For the fourth question, we need to write the prime numbers and the composite numbers less than 20. So let us write separately prime numbers and the composite numbers. The prime numbers are 2, 3, 5, 7, 11, 13, 17 and 19. The composite numbers are 4, 6, 8, 9, 10, 12, 14, 15, 16 and 18. Let us look at the next question, question number 5. What is the greatest prime number between 1 and 10? The greatest prime number between 1 and 10 is 7. Let us look at question number 6. Express the following as the sum of two odd primes. The combination of two odd primes should give the sum as the given numbers. First one, 44. 44 is the combination of 3 and 41. So I'll write 41 plus 3. Second one, 36 is the combination of 5 and 31. 24 is the combination of 7 and 17. Same way, 18 is the combination of 7 and 11. These are odd numbers. Look at question 7. Give 3 pairs of prime numbers whose difference is 2. You have to note this. 2 prime numbers whose difference is 2, it's called as twin primes. Say for example, if you have the combination of 3 and 5, their difference is 2. 5 and 7, their difference is 2. If you consider 11 and 13, their difference is also 2. So such type of prime numbers whose difference is 2, they are called as twin primes. Question number 8. Which of the following numbers are prime? 23 is a prime number and 37 is a prime number. The remaining two numbers, 51 is not prime and also 26 is not prime. Let's look at the next question. Write 7 consecutive composite numbers less than 100 so that there is no prime number between them. Very important thing to notice, consecutive. If I start with 90, 91, 92, 93, 94, 95 and 96, these are 7 numbers. They are consecutive and there is no prime number between them, and all these numbers are composite. Also means more than 2 factors exist. Look at question 10. Express each of the following numbers as the sum of 3 odd primes. First one, 21 is the combination of 3 plus 7 plus 11. 31 is the combination of 3 plus 11 plus 17. 53 is the combination of 13, 17 and 23. 61 is a combination of 19, 29 and 13. Look at question number 11. Write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. Here they are given a hint. 3 plus 7 is 10. 3 and 7 are prime and 10 is a number obtained by their sum and it is less than 20, which is divisible by 5. 2 plus 3 equal to 5 and 5 is less than 20 and divisible by 5. If you have the combination, we will get 20, but in the question they have asked less than 20. We have to make a correction here. It should be less than or equal to 20. If you have the combination of 3 and 17, we get the sum as 20. And if you have the combination of 2 plus 13, we get 15. The 15 is divisible by 5. 5 plus 5 is 10. 5 and 5, they are the prime numbers. So we'll make a correction in the question. It should be less than or equal to 20. Let us take up the last question of the exercise. Fill in the blanks. First one is a number which has only 2 factors. They are called as prime numbers. A number which has more than 2 factors, they are composite numbers. One is neither prime nor composite. The smallest prime number is 2 and it is the even prime number. The smallest composite number is 4. The smallest even number is 2. With this, we have completed the exercise 3.2. Let us continue with the exercise 3.3 in our next session. That's all for today's session, and we shall continue with exercise 3.3 onwards in our next session. Thank you.